Hi Mark. So would you like to
Charlie.
introduce yourself and your job title?
Sure. I'm Mark Crowley. I'm an assistant professor at the University of Waterloo. It's in Canada, in the electrical and computer engineering department.
Sure. So what first drew you into AI?
Right. Well, so I mean, when I was in undergrad, there was AI courses, and it was all about logic programming and playing games and robots and things. So it was very interesting when I was an undergrad. And I went into industry for a few years, worked as a developer, and then when I decided to go back to grad school, I said that's the thing I was most interested in. So I always wanted to get back into it. By the time I went back to grad school, it all changed. Of course, it was no longer logic. It's all about statistics and models and neural networks. So I had to adapt to that a bit.
Sure. So we hear a lot about the potential for AI to cause a lot of social harm and also social good. What are your thoughts on this, and how are you employing AI for good in your work?
Right. Yeah. I mean, I always say that AI is a tool like any other. It's a pretty complex tool that can do a lot of powerful things, but it's a tool that people build to solve their problems, right? So if we choose to use it to solve problems to make the world better, then we'll be able to do that, right? The default that a lot of people have been doing, which makes a lot of sense, is to use it to make money and to do things that are very concrete. So most of the advances we've heard recently are advertising and images and natural language, and it's fantastic. But I've been focusing some of my research on applying AI for good, and especially for environmental and sustainability problems. So I focus on things in forest fires specifically, but there's just a whole range of domains and problems that you could apply AI to. May not make you a lot of money right up front, but they're huge impacts for society.
Sure. So you mentioned there about forest wildfires. How do you use machine learning to improve that? And in what way did you begin this work, and what does that entail?
Sure. Yes, the reason I got into it is I did my PhD at University of British Columbia in Vancouver, and the computer science department at UBC is right beside the forestry department. This is not the protecting forest department. This is the how to manage and harvest forest department. Because you go to this building, it's this beautiful, huge logs and
Sure.
it's very nice building. But so my prof and a prof from there had talked about some problems and ideas that they had in forestry that they wanted to use modeling for. So I got kind of onto one of those projects, and we found that it was actually a very challenging project. So my PhD was on forest, applying AI and Bayesian networks and reinforcement learning to forest harvest management with these kind of spatial constraints. And then later on my postdoc, I did stuff on forest fires at Oregon State University in the US, because there's this program called computational sustainability that the NSF funded, and they try to connect researchers in machine learning and optimization to real problems in environmental domains like forests, invasive species, bird migration and stuff. So I've been working on forest fires since then.
Sure.
I guess in terms of what I'm doing, right now we're focusing on trying to learn predictive models of how fire spreads directly from satellite images, and we're doing that with combinations of kind of neural networks with kind of recurrent links over time, as well as trying reinforcement learning methods for it.
Sure. So how accurate are your predictions, out of interest?
They could be more accurate. It depends on how far ahead you're predicting. So we're comparable to some of the methods being used in forestry now. So I guess there was 70-80% prediction rate of the next frames in these kind of satellite images. But there's a huge amount of variation there, and the challenge with the models that are generated by people in forestry, which are really detailed, beautiful models, is they're quite slow, and they're hard to update for adapting conditions like climate change or for different regions that didn't have the data. So we're hoping to recreate some of those results using sort of straight from data learning, but also improve on them.
Okay, so how do you use deep reinforcement learning in that?
Yeah, so that one's kind of interesting because we try to treat fire as if you hear about, using reinforcement learning is used a lot for video games. So there's these big ones playing Alphago used that, and the Atari games. So we treat fire as if it's kind of like a game, that the fire is the agent that's trying to walk around the landscape. And so imagine, if there's a forest fire happening in certain pixels on your image, every location that's on fire, it has to decide, in a sense, whether it's going to spread north or west or east or south based on the conditions, based on the trees and the wind and other things. And those are all elements in its environment. And so we look at images from satellites and turn them into this kind of environment almost as if it's a game, and try to learn, well, how did it play? How did it move around? And that's what reinforcement learning is good at, that it can learn from experiences, try different things out and see how they work, and then you reward it if it does well, and you penalize if it does badly. And so we essentially treat fire as if it's this agent trying to spread, and we learn from examples that way.
Yeah. So where are you still facing challenges within that?
There's many things. So we're just kind of really just getting started in that realm. We started that kind of 1.5 years ago with the RL thing on forest fires. Data is a problem. So we get certain data from like readily accessible satellites, but there's much higher resolution data out there. So getting access to that is sometimes a challenge. Also just connecting with, like I know quite a few people in forest management and in those forest sciences, but we have to talk with them more and figure out like what are the things that would be useful for them to solve their problems, because we can treat it as our own kind of toy model, but finding out what the real questions are that will help them manage fires better, reduce the huge impacts from them. It's tricky to sometimes find out what would help,
Sure. So what other ways do you think that we can harness AI in order to help the environment?
Oh, there's so many ways. So yeah, my talk yesterday I was talking about the UN sustainability goals. There's just a huge set of things, like for the environment, for like flooding, for water treatment. They have things about disease, about social equality. There's many problems where there aren't, AI companies working on it or a lot of academics. So people have data, and it's there's just many potential areas for it.
Yeah. Interesting. So what other industries can benefit from what you're currently doing? I'm sure there's many.
Yeah, I don't think so much about industry right now. But so I mean, in forestry, we have kind of those companies that are managing forests, and it's often a little bit more the government agencies that are worried about it. But as someone was pointing out, that a lot of the like power companies and insurance companies, they're the ones who have to deal with these kind of disaster response things.
Yeah.
And same for fire, for flooding, even for things like that. And so they want to be able to predict risk and manage it. And figure out what the possible futures are. And so if you can learn from data and build simulations of it, you can help kind of estimate the probability of kind of different high-risk outcomes. So that's probably one of the most direct industries.
A lot of AI research has gone into actually defeating Alphago, hasn't it?
Sorry, what's that?
Alphago, the game.
Yeah.
I remember a few years back, a lot of work went into trying to eventually actually beat a human player on Alphago. What year was that? When that actually worked? Do you
I think it was just 2016. It's just so recent. But they've already improved on that. The DeepMind had that algorithm, and they kind of did additional versions, and now they basically got another version of that that can play against chess and other games and learn from scratch. Yeah, but definitely in research, we're always trying to beat the other people's algorithms. So people try to do improved versions. Sometimes it's hard to compete with industry because they'll have their research idea, but then they also have huge computational servers, so they can run a lot more experiments. But the idea behind their Alphago algorithm is quite, elegant and straightforward once you see it, and it works. So they had a great idea, and it worked.
So what's next for you after this?
There's lots of things. For the forest fire problems we have, we're trying to build a more detailed kind of simulator we can use for training, because one of the problems is we get access to simulators from industry or the government, and they're very slow and wonky to use for our purposes, because they weren't built to be used for machine learning. So we're going to build our own simulator and try to open source it and make it online so people could use that, and hopefully make some of this domain be something that other researchers could use as a test bed, because I think it has a lot of complex structure and elements to it that AI researchers could use, and it would get people sometimes out of the box of using the standard image data sets and language data sets.
Sure. So where can we keep up with you online?
The easiest way to say is on Twitter. I'm at compthink.
Okay.
Because my blog is computationally thinking, but you can also look up my website, University of Waterloo. Yeah.
Okay, perfect.
Yeah.
Well, it's been a pleasure speaking with you, Mark.
Great. Thanks a lot, Charlie.
Okay.